So in each of the strata we have n1 number of individuals, n1 if it is S1, and n2 from the second one. Okay, so all together if you wanted to get the total population, so you will add n1 with n2 to get the total population, because in one strata you have female, in another strata you have male. So if you wanted to get the total population, you have to add them together, n1 plus n2 to get n. So once the n is there, so it will be called a total population. So once the total population is there, so it means that, for example, if our study is concerning with the gender, so this formula for n, the numerator, I'm talking about the numerator, so this will be expanded. So in this case L will be considering a value of 2, because our population is split in two parts. So it means that you will expand these terms equal to n1 square sigma 1 square over sigma 1 plus, because this is a summation, plus n2 square sigma 2 square divided by sigma 2. Okay, so that's how you will expand your numerator until two so you will expand until two terms, because we have a population splitted in two parts. So if you have splitted your population in three parts, so it means three strata are there, then it means that you will have another term with n3 square sigma 3 square divided by sigma 3. So if you will have 4 strata, so then plus again n4 square sigma 4 square divided by sigma 4. Okay, so in that way, so you will keep expanding your, this term is according to what number of strata, how many number of strata we have, we will expand according to the size of the stratas. Clear? And then the denominator is very obvious that it is belonging to your population, and population n is of course will be estimated according to the number of stratas, and then d will be estimated through the variance or through the boundary error. Okay, so this is sorry, a is not a sigma, let me make it little bit mistake here. This is ai, so a1 a2. Okay, so this is not a sigma, rather a. So now we'll be moving, I think, in so you have to pick different d according to the your estimator. If your estimator is mean, so you will be having b square over 4. If your estimator is total, so this symbol belonging to mean and this symbol is belonging to the total. Okay, so for each of the case your d is different. So you have this d when population mean is given, and you will have this d when population total is, so when your question is related with total, so you have to have your d is equal to b square over 4m square. Okay, so this d will be depending upon what type of question you are having. So in example number 5.5, a prior survey suggests that the stratum variance for example 5.1 are approximately, so we have taken this data from example number 1, and for each, so there are basically 3 stratum in that example number 5.1. So in each of the stratum the sigma 1 square and sigma 2 square and sigma 3 square is given. Okay, so these sigmas have been given. Sigma mean the variance. Which variance is it? Population variance. Population variance is given here, and then we wish to estimate the population mean by using y bar. Choose the sample size to obtain a bound on error of estimation equal to 2 hours. Okay, so bound on error of estimation is given by 2. So what is the meaning of it? The b is given. When bound on error is given, it means capital B is given to you, capital B. And if the allocation fraction are given, so A1, A2, A3 is given, so it means that your sample, whatever n you are picking, so it will be having equal amount of distribution in each of the strata, from each of the strata. So all the data is here. The bound on error for 2 hours means that, so 2 into variance of, so we already know the formula. Okay, so 2 into square root of the variance of y bar is called the b. That is the formula of the b, bound on error. Okay, so if the bound on error is 2, then variance of y bar, this 2 will be divided to 2. So we have variance of y bar square root equal to 1. So if we take the square on both sides, so we will have variance of y bar equal to 1. Okay, so that is how the variance is calculated. Variance of y bar is equal to 1. Out of the bound on error, we could calculate the variance of y bar. And therefore d is equal to 1. So we wish to estimate the population mean. So this question is related with population mean. So it means that for d, which formula will be used? B square over 4. And what about the formula for the total? 4n square. Okay, so the bound on error is 2 raised to power 2. Answer is 4, 1. So that's how d equal to 1, it is mentioned here. So still the recording is going on. And in example 5.1, in the same example, because we are picking all this data, we are selecting all the data from the example 1. So n1, which is given 155, n2 62, and 3 is 93. It is given. Now we will be calculating the term that I told you, the numerator of the formula. Okay, this term is basically the numerator of that formula for which is used for calculating the n, numerator. So in numerator, I told you, if your population is separated into 3 parts, so then you will have, these 3 parts. So your formula will be separated in 3 parts: n1, n2, n3. n1 square sigma 1 square a1 plus n2 square a2 square a2, n3 square a3 square and a3. So that's how you just need to put all the values. So 155, when you're putting 155, 25 from the given data, sigma 1 square variance, which is given in the example, it is mentioned. So all the values it is mentioned, and ultimately we are obtaining the numerator, this number. Okay, so in the denominator, what we have in the denominator, d, if you could see the formula, in that's what we have calculated, this one. It is estimated. Now n square d. So n square is, how do we calculate the n? N is equal to n1 plus n2 plus n3 equal to capital N. So once you have the capital N, so you have to take the square of it. So you will have that number, and d is equal to 1 already. We have estimated that. D is equal to 1. And the rest of the term is this one. So this term will be expanded. This term will be expanded by, let me show you. Now in the denominator, this term will also be expanded in three parts, because we have three stratas: n1 sigma 1 square, n2 sigma 2 square plus n3 sigma 3 square. So that's how the denominator is expanded, and we have calculated the value 27,125, and n square d is equal to 96,100. So all the terms have been completed. Now let me mark all the terms. So which have, so this one, the first one, second and third, all the terms have been calculated. We just need to put all those values inside the formula to get the sample size. N is equal to 56. Okay, n is equal to 56. Now we could easily estimate out of n. So we, since the n was not there before, small n, okay, so it means that once we have the n is almost 57. So what is n1? 1/3 of the 57. What is n2? 1/3 of the 57. And what is n3? 1/3 of the 57. So that is the allocation for each strata, sample size for each strata. So it is almost 19. Okay, that is almost 19. So you just mention this type of for approximation. So that's how you will be obtaining sample size for each, and the capital the sample size for the population. Okay, so n1, n2, n3, these are the sample sizes for each strata, and this small n 57 is the sample size for the capital N. Okay, now I think this topic is finished. So let me stop it and then